Hello, and welcome to a tutorial on creating your first C++ program. Traditionally, the first program we create is called Hello World. We'll be using Visual Studio 2019 Community Edition to create that for us. What we're going to do is we're going to start Visual Studio 2019, right? It's already showing in my menu, but if you start typing Visual Studio in your search bar, and this of course assumes you've already installed this, as we've done in an earlier video. Right. The program starts and it gives us some options. The option we want to choose is create a new project. And what we're going to do is we're going to choose console application, so console app, and that will actually create the Hello World project for us. We'll click on next. It's going to ask us what we want to name our project. You can go with the default console application. Here, I'll just call this one Hello World. It gives you a default location to store the files. I think I will just go ahead and select my desktop for this one as the folder. What it will do is when it creates the project, it will create a project folder for us. So that's going to go on my desktop. We're going to let the solution name be the same. We really don't need to be concerned with solution name, project name right now. Where we place those directories, we'll just click on create. And Visual Studio will quickly pop up. And what it's done is it's created a C++ file for us. So in using this IDE, which stands for Integrated Development Environment, there's a lot of windows that come up initially. So it's a lot of information. Over here under Solution Explorer, it has some file folders it's created for us. Getting started right now with C++, we're only ever going to have one file that we're concerned about, and that will be a program source file. So when we write program code, programming statements, we call that source code, and those go in source files. So what it did is it created a file called helloworld.cpp for us, which is this file that's open here. Our C++ programs will have the file extension .cpp, right, for C++. Now, there's a lot of information here within this program source code. What you see in green in front of you are called comments. Comments are ignored by a computer when your code runs. Comments are for humans to read, right? They help us to understand things. And they've then added some comments to help you get started. Right? So what I'm going to do is I'm going to go ahead and get rid of some of these initial comments here. They're giving you some instructions on how to run the program. I'm going to get rid of that. So we're going to get down to this very simple C++ program here. This is the source code that we need. And what we can do is we can just go up here and see this green triangle, local Windows debugger. If we click on that, what it's going to do is it's going to go through a series of steps called compilation, linking, and creating what's called an executable file, our source code file, to have that running, right? And whenever you build something, as we'll do in our various examples, it will get some output from when we're building. If there's errors, it will tell us about the errors that it encountered that did not allow it to finish building our programs. Here, of course, it wrote the code for us. There were no errors. And what it did was it went ahead and actually started running the code for us. And it pops up what's called a console window here. So let me minimize some of that in the background. So it popped up this window, Microsoft Visual Studio Code Debug Console. And now here is our program output, Hello World. Right? It's giving me some other information about where it stored the file, how it ended. Importantly, then press any key to close this window. Right, so you can actually hit this to close the window or press any key on your keyboard. Right. Right. What we want to do is, since we're going to be writing C++ programs, is we want to take a look at the source code in here and understand why some of this code is in here. Right. Teaching a class this fall, I'm actually recording this, right, for my students. So I'm going to pop up some lecture slides here, and we'll take a look at the meaning of some of these statements. Right. So one of the first statements we saw was this pound include. Pound pound include IO string. What we'll find is that whenever we're working with input and output in C++, we have to include a library that handles that. Right? And that library of functions that handle that is stored in a file called IO string. Right? So and whenever we want to use functions and libraries that are external to our code, we have to know the name of what's called the header file or the name of the library. And we tell that to include this. So we use this pound include statement here in our program. Pound include statements don't end with a semicolon. We'll take a look at that statement in just a moment. So the IO stream library contains then some different objects that have been defined. In our case, we're using cout to print to the screen. We will commonly use cin. If you think of in for input, to read information from the keyboard, that's known as the standard input stream. Cout, this object, the stream it writes the characters to, right, is the standard output stream. And that will show up on our display screen. Right? There's some other streams as well, carr and clog, that we'll talk about much later. So IO stream, we'll use it whenever we want to display information on the terminal or if we want to read information from the keyboard. Using namespace standard. So there's a line in there called using namespace standard. A namespace is simply a way to give a group of functions or variables a specific name that they belong to, or namespace. Right. When we write code, we've written one very simple C++ file. When you think of all the code that's executing on your computers, there are millions of files. And so a lot of that code includes a lot of these different libraries where some functions or some variables may have the same name. When they have the same name, it creates what's called a name collision. And all of the standard library functions that we'll be using, the IO stream, have been defined under a namespace, and that namespace was called std for standard. Right. And let's take a look at this back in our program here. All right, so here pound include IO string. Now Visual Studio didn't include the using namespace standard. What they did was here we have what's called a scope resolution operator, this double colon here, with the namespace std for standard. So that's one way you can write your code. If we get rid of this standard here and we change this to using namespace std, then cout belongs to this namespace std. And if we just hit local Windows debugger again and run it, we still get our output hello world, right? No errors. This statement is very convenient to use so that we don't have to type std : with all the objects that have been defined in that particular namespace, right? So the std : with the italicized that's on here starts bringing up a list of several items that have been defined within that namespace, right? There's a lot of items. You'll find that when you write your code, right, especially for beginners, sometimes it's very tedious to go ahead and put the std : in front of every single object that requires it. So some teachers will allow you to have this statement in your program using namespace standard so that you don't have to do that. And in the beginning of my classes, I allow students to do this for the first few programming assignments, just because there's a lot of syntax that they're already getting used to. And I will do this in some of my examples just to make the examples more readable. However, we will transition at some point to using the scope resolution, the namespace resolution. So I would like to show you what happens if we remove this. So if we remove using namespace standard, and I don't use the std : here, If we just go ahead and hit local Windows debugger. So one thing I should mention is whenever you make a change to your program, you have to rebuild it again. Right? So when we hit this, it actually saves our file, it rebuilds things. And now you can see a window popped up telling us there were build errors. And it gives you the option, it says, would you like to continue and run the last successful build? Well, I don't want to run the last successful build. So I'm going to hit no. I want to know what my errors are. And so down here, it says identifier cout is undefined. Right? And what's nice is you can see that this red line here is indicating this error. Right? And if we hover over that, we see identifier cout is undefined. So that's a common error that we make, that we forget to put std : : if we're not using the namespace standard, right? So we run this again, right? Everything works. So if you don't have using namespace standard in here, you do need to use this scope resolution with everything. So let's put this in. It's not the best practice to do that. So you may want to get into practice in the beginning of not using this. Right. All right. So now let's take a look at this statement, int main. Every C++ program starts program execution in a function named main. So the name of our function is shown right here, main. There's one main function in every program. It's required, but you can only have one. You can't name any other functions main. We're not writing other functions yet, so we don't have to worry about it. It has to be spelled just like this, all lowercase letters. After this, we have a left and right parenthesis. So whenever you define a function, you have to give what's called, you have to give the function a name, and you have parentheses after it. For main, right now we have nothing that goes in between the parentheses. Later on, we will. Also, a function always has to have a return type. We haven't talked about data types yet. Int is a data type for integers. So for right now, just know that whenever you write a C++ program, you're going to start at int main, left parenthesis, right parenthesis. After that, then we have a left curly bracket. This curly bracket denotes the beginning of our function main. And the first programming statement immediately following the curly bracket is the statement that's executed. There's only one programming statement in this example they gave you. Cout looks like a double less than sign, this message, hello world, and a \n here. So as we've said, cout is this object that allows us to write to the screen. So we have to have the cout there. And then with cout, the syntax that we have is what's called this insertion operator. And it inserts the information following it into the output stream. So for a beginning programmer, I say whenever you want to print something to the screen, right, you're going to get used to the syntax. You're going to have cout less than, right? Now, typically we need this space in between, or it will think this is all one word. So after then, the insertion operator, the double less than sign, we put a message that goes inside double quotes. And what we see printed on the screen, so let's run this again. What we see printed in the output here is we literally see these characters, HELLO space WORLD exclamation point, but we don't see this \n. What this \n is it's called an escape sequence. And what it does is it prints a new line. So when the code prints out here, if we were to print something after this, right, what it's done is it's moved the cursor to the next line. If we were to get rid of the \n here, rebuild this, notice after our hello world, we don't have a blank line like we did before, right? The program ends at that point. Let's try a little experiment here. Let's put the \n and let's put the message hello again after that. And let's rebuild this. Notice that in our output, we get hello world exclamation mark all in one line. The \n that we had here says move the cursor down to the next start of a new line. And after that, then start printing the characters within this set of double quotes. So we see the hello again. So we got the two messages here. All right, we'll talk more about uses of cout, in future examples. All right. Finally, there's one thing missing here. Typically, we end main with a statement return 0. Right. That return 0 statement, whenever you write functions, functions have return values. Some compilers let you get by without putting in this return statement here. As I teach you to write C++, we're going to put the statement in here. Right. So what return says return from the function. So as code executes, if we have the second statement here, this first statement runs, then the second statement runs and returns 0. Right. Well, by convention, 0 is just the number that this program is going to return back to the operating system. We can make this any number. It would have to be an integer number. The reason it needs to be an integer number is because the return type of our function is an integer. But if we were to just run this again, our program output isn't going to change. We've got our two messages, hello world, hello again. Here where it tells you this program exited with code 0 is this particular 0 we wrote here. Let's just change this to 99 and run this again. And now you're going to see the message says that this program it built. So when it creates a program that will run, it named it with our same name of our project, hello world, and it added an extension called .exe, which in Windows is an executable file. That's what's actually running here. But notice it says it exited with code 99, right? This is the number of the code that we return to the operating system. This isn't real important to us because we're only running one program, but oftentimes many programs are run together. Sometimes one program can call another program to run, and that program will perform whatever its operation is and then return some information to the other program that called it. So sometimes those return values are important. And when we start writing functions, we'll return some values. If our program calculates things, we'll learn more about that return statement. But for now, our convention is return 0 within main. And if we had other code after the return, like cout the end, this line of code will never execute because what this return statement says is it says return from main. And whenever you return from main, that's the end of your program running. So this code will never execute. Let's see that. So let's rebuild this. Notice again, right, our window pops up, we get hello world, we get hello again on the next line, and we do not see the statement cout the end. It didn't execute because we wrote that after return 0. So order is very important in programming, right? And so if we were to move this up here, right, and now rerun this, all right, we got hello world, hello again, the end on all on one line, right? This statement actually did run. The reason this is all on one line is after the hello again, notice there is no \n. There's nothing to tell the cursor to move to the start of a new line. So even though we have another cout statement, as soon as it starts printing out, the cursor had stopped right here after the n and again, right, was in the next column, and the next message started there. So if we wanted to start this next message on a new line, we'd have to add in that new line character there. All right, and so now we get each one on a separate line. All right, there's lots of different things we could do with this. I've already probably drug this out longer than it needed to be. In future examples, we will take a look at more uses of cout and how to create programs with variables. All right, so thanks for watching. You've created your first C++ program. As an exercise, instead of printing hello world, why not change the message to print out your own custom message, or maybe print out your name, right? So you can customize it for your use and get a little bit of practice with that. All right, so I hope you enjoy your journey in learning to program in C++, and I will see you in a future video.